another visitor that is making me extremely happy, and this is Ken Gracey. Hello, Ken.
How's it going, Jake? Good
Ken,
morning or good
Ken,
afternoon. Hi,
Tim,
Julie.
Tim,
Hi.
Tim did a presentation earlier in the day, and he was talking about your products. He showed some videos. He talked about what his students did. It was really good. So we're looking forward to this. Ken is a lifelong hobbyist and educator and a CEO of a company called Parallax. And Ken has been doing this for a long time. I have manuals that Ken's company published in the early 90s. So it's been quite a while. Um, so Ken,
Well, if
this
it's fun, you just keep on doing it, right?
it's great. So I'd love to have you explain what you're doing and what all this has to do with education and getting ready for the future.
Yeah, sure. By the way, it's great watching Jen and Oscar previously. I think this kind of ties together with what they're pointing out, being teachers and using tech when you're not a tech teacher. In Jen's case, is great because you do have to be able to write about things and communicate everything you're doing. So that was really good to watch her. Sure. So I'll tell you a little bit about what I'm going to show and who I am. My name is Ken Gracey. I'm from a company called Parallax in Northern California. And we make microcontrollers, robotic parts, and tutorials for students. I'm also a preliminarily certified CTE teacher, and I've been at this thing for about 25 years. And I followed a lot of the science fair and the maker fairs and the innovations that are happening with students like the Invention Convention. And I'm seeing how that they are really progressing. Like these kids are getting really good. They're doing better stuff and we're seeing more electronics in it. And because we make electronics, I thought I would show two things that I've been working with lately that I think hold a lot of promise for both inventions and student-oriented projects. So I'll run through these projects really quick. The two things I'm focusing on, one is using a camera to identify objects of different colors and where they are. So I believe we'll be seeing a lot more of this kind of sensing used in some student projects. And then the second item is just a really easy demo of how you could communicate wirelessly with something called the Microbit. It's a very low cost controller, and I think it's useful for any student because you can program this in block code or Python or whatever. So, no, get rolling. Yeah, so the Pixie2, the first project I'm going to show you is called the Pixie2, and that's a little camera that you can interface with a microcontroller. And I want to work with color items because I want to do more advanced work. I want to count objects, identify them, sort them, move them around, whatever. Because for years in educational robotics, we've been using these kinds of sensors, which are sensors that detect things and their distance. Like laser sensors could work up to 100 meters. Infrared can detect people walking into a room. Infrared emitter receiver pairs can tell you when something is nearby. Ultrasonic sensors work up to 10 feet. So there are a lot of good technologies, or even physical bump switches. But these are all just detecting whether or not something is in front of you. Something, I say, because it could be almost anything. But whether or not you can see it depends on the technology you're using. Like a fuzzy stuffed animal may not be seen by an ultrasonic sensor. So students get to learn about these things pretty quickly. This is usually where they go. I think where they're headed, though, is to do things that are quite a bit more complex in time, because I'm seeing it now. So for example, here's a robotic arm, and this is moving around some items of color, like some little round discs, picking them up, placing them somewhere. Or how about this? This is a little more human-oriented task. Picking up an object. What color is the object? What do you do with it? And then we're seeing some stuff like this, conveyor automation type things. Also really neat, Legos can factor into this. And we're seeing games that can be played against robots. Okay, so if you can track a color object, you can actually create some kind of actuator to attach to it, hit it, or bounce off of it, or move a chess piece or whatever. And of course, we see a lot of robots like this. Okay, so what happens, let's say you got 100 objects in front of you. We're humans. This is easy. Count the yellow balls, 1, 2, 3, 4, 5. You can do that, no problem. But what's a microcontroller? What's a robot going to do with this? I mean, this is like absolutely complicated to deal with if you're a machine. It's not easy. And even though we have a tool now, and there are many that can identify these objects, count them, sort them, what do you do with all that information? How do you code around it? I mean, this gets really, really tricky really fast. So my little project that I used to learn about this started out like this. So I'll show you the beginning, then the end. So here's a little robot, and it's just tracking this yellow block. And so this project probably took me about a week of coding to get to. But the great thing is, every time someone goes through this process, they post the code and they share it. It's available for others. So I'll provide links to this in the chat at the end. Okay, so that's where I started. Now, where I wound up was somewhere kind of different. So you got to look at these projects in pieces. You have to break them down into little pieces when you're working with this or when students are. So this is some advice I can give you. It doesn't require a lot of skill. You can learn online how to do these things, but you have to be able to do subsystem testing. You have to break these problems down into little pieces with a block diagram. So here's a block diagram of the problem we're working with, or I should say the hardware. What I'd like to be able to do is pick up the yellow cylinder and move it around. So I have 3 pieces to this, really. I have the robot, which is shown in the top block. Okay, so that has a little chip on it. And then I have this Pixie2 camera, which can detect the object, and it talks to the robot. And then I have the object itself. So I got these 3 things. An environment has everything to do with making something like this work. Again, we take this for granted as people, kind of like Oscar was showing that drone flying around, in a closed area, indoor, it doesn't have GPS, has to detect objects. We take this all for granted because it's so easy for us as humans. So let's look at one piece of this at a time, just briefly. All right, so to configure a camera, you first have to teach it, the camera microcontroller, what it's looking at, where it is, and then it will generate information that will go out to you. So in this case, I just put 3 blocks down, and I hooked the camera up to its PC software, and then I could train it, and I could say, this is a green one, and I do that by clicking on the block, outlining it. Here's a yellow, here's a red. So the camera now knows what it's looking for, and once these colors have been trained to the camera, it can count them and tell you the size and the location. Okay, this is pretty awesome, pretty powerful, and pretty easy too. Then you got to write some code. And again, as I mentioned, this work having been done by many people, it's available, it's online, not just for this, but for other things. So for students doing projects, we really just have to help them find the resources and get them the hardware. So on the microcontroller side, where the robot is, we wrote some code, and we did this in Blockly. And this is a pretty big program. It has 500 blocks in it, so it's pushing the limits. And all these things on the right, these are functions that are all collapsed. And if you've worked with Scratch or Blockly or Snap or whatever, you know something about this already, but you can take big chunks of code and then collapse them. And so the main program's here on the left. And it does things like it goes out to the camera, and then it says, what are you looking at? And then the camera returns a bunch of data. So the camera being trained, you have to interface it to a chip, to a microcontroller, and then get data, numbers, out of the microcontroller. So this is what the microcontroller would see, looking at those previous objects. So it's looking at these things, 3 blocks, and then it tells you which color signature it has. So here's 1, signature 3 might be the green, and then 1 might be the red, and then 2 is yellow. And then check this out. For each of those items it sees, it tells you the X and the Y position in its coordinates, and then how big it is. both in the X and Y dimension. So you got all this data. Now, go back to that big old bucket of colored balls that was dumped on the table. Imagine now trying to sort through what to do with 50 different versions of the same color on your screen. Oh my gosh. Yeah, I see Julie. She's like, this is complicated. Yeah, so you have to simplify your problem to make it useful and demonstratable and solvable sometimes. Anyway, here's the result that I got out of it. So after, working for a while.
And it wouldn't look as complicated 23 hours ago.
Yeah, exactly.
In a way, 24 hours makes a difference on how we look.
You guys are hanging in there. So what happened in this video, and I'll play it again, is the robot took an inventory of what it was looking at, swept from left to right, and it was coded to go for the yellow one. And so it determined where it was in its X and Y viewpoint, and then just went after it. And again, I'll post all these links in the chat, so just hang on a minute. Because, as Jen pointed out, tech integrates with writing, and if you're going to be useful in anything you do with tech, you have to be able to communicate it. And this is a requirement we have as an employer of anybody in tech, is that they have to be able to write. You could be the best engineer in the world, but if you work alone and you can't work with others and you can't share what you've done, it's really of no use. So in this case, this project is written up for you. So the second thing I wanted to show that I'm playing with too, and I think this is really good for students to be using in any invention type project, is the Microbit. And why do I like this thing? First off, there are a bunch of ways to program it. You can program this in block code, JavaScript, Python, whatever. What I'm showing is in Python. And one feature in particular here that's really nice is the wireless communication. Okay, wireless is all around us, our phones, our routers, everything we're doing. Even any appliance you buy now has some wireless capability. So this is a little $17 controller that you can buy just about anywhere now, and it's loaded with stuff. So if you think about the inventions again, so just look what's built in here. No electronics needed. It's all packed onto this board. You got a compass, accelerometer, there's a temperature sensor, there's a wireless radio, there's a bunch of LEDs, buttons, okay? So you can connect this to anything that moves, shakes, has temperature or whatever, and if you still have to connect stuff to it, you can use this edge connector. Okay, so I like this little tool. And what I was looking at here was just the ability to use it in robotics, well, because I make robots, and how easy is it to do. And so I started out with this project, but wait till you see where I went. It's pretty cool. So just driving the robot around using the accelerometer, that is, you tilt the board and the robot follows. What do you think of that? It's cute, right? Now, a sixth grader can do that. Okay, so got to have you picture a situation here. You have a student, actually a classroom full of kids. Let's take 30 of them.
I saw some of Tim's kids. I saw his 2 sixth grade classes, and it was amazing. Some of them had their stuff done. This was way back in November, so they weren't all finished, but they were using the Parallax boards, and I'm not sure what you call the totality of what you have, the equipment they got from Parallax, and they're pretty phenomenal little things. They demonstrated a few of them for us.
Well, it's a matter of being a teacher, just throwing it in front of them and finding the resources. And all this stuff is new, so not every teacher can know about it. But experiential learning, letting the students discover it is really what it's about. We all want control. So I want you to picture class, Tim's class, or Jake's class of like 30 kids, and they're all on their computers, and they have these little microcontrollers connected to them on a USB cable. And they suddenly open up a chat in them, and that means they're typing commands on their computer which are sent out through their microcontroller to other students in a very open, unencrypted way. So it starts out just with fun, but then it turns a little bit crazy, and then suddenly the teacher needs to shut things down. because it can get out of control. So there are only two lines of code here. This is the whole code that I'm going to show you running here. It's 24 lines, but 2 do all the work. That's radio send and then radio receive. So it's a little loop, and it's just checking to see if anything's come in and if anything can go out. So this allows you to take one controller, connect it to something like a sensor, and then say to send data back to a computer. Let's look at this application. Okay, so say you've got, this is actually my computer, and what I have is two browsers open side by side, and I have 2 microbits connected to 2 different USB ports. So it's like having 2 computers on 2 students. And the tutorial documents this. Doesn't require any expensive hardware, nothing special from Parallax. Like I said, you can get these things anywhere. So basically, you're going to load the code into both microcontrollers, and this video I pre-recorded, so I'll switch over here. Here it should. Okay, so I'm going to flash them both with the same Python code. And then after that's done, you'll do what's called opening up a serial terminal, okay, on both sides. And now you can communicate across the room. So I send a message. Why was 6 afraid of 7? And everybody in the room receives it. And anybody can type back too. And I answered my own joke because 7, 8, 9. Okay, so that's the kind of stuff that's possible. Where I wound up was here, actually. I wanted to control a whole classroom of robots. Well, this is what our customers will want to do. So this is part of teaching cybersecurity. You start out with things totally wide open, and then eventually you can control the whole classroom. So type in some commands on the computer. And then you can see every single robot can respond. Yeah, pretty crazy, huh? Fun. Yeah, so I'll post that. And let's see, how are we on time right now? I'm just about done.
No, you've got actually about 15 minutes left, I think.
Oh, okay, good. I won't even need it all.
Yeah, let me look to make sure, because I could be totally wrong.
But there will be some questions there.
Yeah, we'll take the questions and use it for
You're on
chat.
until 11:30.
Oh, okay, good. All right, so teachers who want to get into this, or students, anybody interested, there are a couple ways to go about it. I will post in here momentarily all the links to chat, and then we could just talk about whatever. But this is a good way to get started. This we actually created for the Invention Convention. It's called the Inventing Kit, and there's a series of slides that go with it and show how students how to wire things on a breadboard and then write some code for it. It's nice, fun, basic stuff. And if you're a teacher, you can sign up for this, which happens next, actually the second week of June. We are running a 3-day, hour-and-a-half per day workshop with Python and robotics. And this is free for up to 80 teachers that we accept. And it's actually paid for by the Cyber Innovation Center. And they're funded by Department of Homeland Security. So it's only open to American educators because of that restriction, but there is no cost in it. So I'll drop this link in the chat as well. And yeah, we could talk about whatever now, and here come all the links to look at. And I can go back to any of those items of interest too and go over them more.
Very good. Ken, thank you very much. One of the things I just want to point out, and Ken, you did an excellent presentation. And it was a very accurate presentation, but it also involves some rather large words every once in a while, like, microcontroller, which in some situations might sound a little scary. But you might want to talk about a little bit about what Tim had done with his students, because his students were in 5th grade. Very, very young students, and had no trouble working with this. It was great.
Yeah. What Tim did is, well, we just put a bunch of hardware in his class, and we actually gave him resources that were intended for an older audience, like high school, and see what happened. And Tim is such an open-minded teacher about these things. You know, what he didn't know didn't bother him, but he just plopped in front of them, and the kids wound up producing all kinds of little contraptions and just learning as they go, not knowing the rules of the game or even the intended outcome, but succeeded. And I think they had a wonderful time, and he's still using all this. Is that an accurate representation of it?
No, absolutely. And it was just, it was exciting to watch the students grow because he told them, he said, by the way, we have all this equipment, and I don't think you're going to be able to do this because this is meant for high school students, and you're only in fifth grade. And so
reverse psychology there.
Oh no, I don't think it was reverse. He was covering himself because he had told the principal that he was going to do this. And I mean, I was just really impressed with what these kids had done, and the excitement. I mean, the nice part about this is Ken showed a lot of robots that were moving. What he didn't show was all the blinking lights and the flashing lights and the OLED screens, you know, with things going on. And the kids really enjoyed, you know, all the blinking, flashing, making sounds. They made musical instruments. It was really exciting.
Yeah, I think I was just talking about sensing, right? Just sensing something you can see, but there are sensors available for measuring just about everything now, and they're getting easier to connect. So these sensors are just for distance or detecting something, but anything in your physical environment now can just about be measured.
I could see you coming up with 1 to 500 challenges that could use this equipment.
Oh, I would love to. Yeah, I mean,
she makes some pretty cool challenges, and I think
I'm typing them in my phone right now.
I mean, most of them are things you don't have to necessarily spend money on. But, you know, as we want the kids to start learning more and becoming more able, sometimes there's a small cost associated with that. But I could see some pretty cool challenges that you could come up with.
You know,
Julie, you could use this.
I'll just share something with you. The most exciting time in my life was the first time I ever programmed a microprocessor, and I got an LED to blink. That's all that it did. It turned on, it turned off, it turned on, it turned off. And I mean, I was just so excited because once you have that very simple ability, then you can go off and do anything in the world. It's just amazing. And while Ken showed some very sophisticated things, just turning on an LED on and off, or turning on different LEDs and lights and making different sounds, it's a really exciting opportunity for students.
So one of the particular resources I like, and I think this is suitable for just about anyone, is this particular site. It's the Make It Code It from Microbit, and I pasted this into the chat. And you can come in here and identify the language you want, whether it's MakeCode, which is their block code, or Python, and then pick on a project and actually see the code for that project. So for example, let's just say I want to pick on Python, and then I want to do a beating heart, a very simple project. Click on this, and it describes the project, and then as you scroll down, you'll see these two options, make code in Python. And so there's the equivalent. This just came out. This is a useful site, and I would say anyone that can read can do this. Especially if you can hook something up to a computer, just plug it in. And once you've clicked on the code you want, like Python, I prefer, you can just open it in the editor right here and then download it straight to your microcontroller. So yeah, easy. In terms of cost, one thing you mentioned, the costs are coming way down. So once you have a microcontroller, you know, 10 to 15 bucks, 20 bucks, then you can go to Amazon, and there are some super low cost sensors, like we're talking $2 to $5 that you can interface to these devices. You just want to do a little Google search on the sensor and the name of whatever you're using.
Very good.
Yeah, and want to thank you guys for the lovely opportunity. I think what you're doing is really cool. I only got to watch a few of these, but wow, what a resource to be kept on YouTube forever.
Well, we've recorded this.